Hey everyone, welcome back to 888 Reviews. In today's video we're going to go through customizing your flipperzero with a custom 3D printed shell. I printed a number of sample casings to replace the factory shell and I'm going to share the results with you. If you're interested in the 3D model I used, you can find the link in the description below. So let's dive in. Printed these samples on two different 3D printers, a Bambu Labs Carbon X1 with AMS and a Prusa MK3S Plus. I've experimented with various materials such as Bambu Lab Black Polycarbonate, Bambu Lab Carbon Fiber PLA, Prusa Galaxy Black PETG and Prusa Black ASA. I've tried both organic and standard supports and I've tested different orientations for the prints. Let's go through each of the prints and discuss their pros and cons. So the first print, this was in polycarbonate. It was printed on the Bambu Labs. It was printed facing downwards, so inside down. So the outside is not too bad. No major issues. Obviously this detail wasn't got. We do have our 4 screw holes. They all come out okay. But then internally, yeah, this is a mess. The supports were quite intense, very hard to get them out, and in the process of getting them out some components got torn out as well. So we also are missing some features. We have no clips here for clipping the two together, so you can't clip them together. We're also missing some of the screw holes here. They're filled up, very hard to use. So yep, this one's unusable. Next up, this polycarbonate. Again, this was printed the opposite way around, so this was printed face down. So the interior is pretty good. We've got all our details. They came out pretty okay. Yep, everything seems to be where it needs to be. We have our clips for clipping it on. They're not the greatest, but they'll work. But then this side, well, this is not so good. We got a lot of roughness. It's very hard to get the supports off here again with the polycarbonate. But this side here, on this side, okay. But this is a disaster. So, useless. Our next one, this is PETG, Galaxy Black PETG from Prusa. So this particular one came out pretty well. All the details are where they need to be. The interior came out pretty good. Again, it was printed this way down. So this is usable. We do have a jammed hole here. This is the only negative piece on this one. But other than that, pretty good print, pretty usable. And we'll try it out. Next up, another PETG. This was a disaster. Everything else the same as the last PETG, but yep, unusable again. So part of this is removing the supports, part of it is printing on the supports. It just doesn't come out right. This is ASA, Prusa ASA, printed this way down. So the interior had supports in it. The interior print is pretty good, but we do have issues. We have issues with missing pieces, missing clips. Part of that is from the print, part of that is from removing the supports. Overall, looks pretty good, but yeah, it didn't turn out so good for actual usability. Another ASA, printed this way. Again, this part came out pretty bad. Removing the supports was very difficult and caused a lot of issues, a lot of problems, and of course some of the screw holes are filled in here and here, and pretty impossible to remove those supports. So yeah, this one's unusable. Another ASA printed this way. So this is good, very usable. Screw hole's good, but then when we go into the interior, it's not the best, and our clips missing on one side. Again, that's down to removing the supports. Not terrible, but not usable. Now we're moving on to carbon fiber PLA. So carbon fiber PLA printed that way. Got most of the supports out, but managed to damage it while I was doing it. So yeah, missing clips, not very usable. Outside print looks pretty good though. Another carbon fiber. So this is printed this way down using supports. Usable. All the holes except for this one, all clear. Top half came out really good, very impressive, but ultimately it's probably not usable because of this. We could drill it out, but yeah, it's not going to be perfect. And lastly, carbon fiber PLA printed using Bamboo Labs support for PLA. So very easy to remove the supports. In fact, there was no effort at all in removing the supports. Simply lifted off the board. Yep, supports were removed. There are some small issues, and some of the print, if we can get a focus on it, some of the print is not great that sat on the supports. Here again, not great, lots of layering. This is from the PEI sheet on the Bamboo Labs. Interior, very good. Again, interior very good, but yeah, printing on the Bamboo Labs support for PLA doesn't seem to produce a great result. So fine-tuning the standard support seemed to do a much better job, but it's very usable. So all in all, not bad. Let's assemble it and see what it looks like. Okay, time to disassemble our flipper and put it into the cases. There's a couple of things to note here. I'm not going to remove this plastic screen. There's no point in doing that. Obviously we're just testing this out. So by removing the screen, I think it's glued in, it's going to be a pain to put it back. So we'll leave that in. There's also a antenna at the back here. We're not going to remove that. We're going to leave that out because also same thing, it's glued in. To remove it would mean that we would have to damage that and potentially cause issues with putting it back in again. So just for the sake of testing it out, see what they look like in the cases, we'll take the innards out, we'll take the switches and we'll put them in the new cases, see what they look like, and go from there. So first things first, remove your micro SD card. You don't want that broken. So you have 4 screws at the back. You need a star head screwdriver, pretty small one. We'll remove each of the 4 screws. They're all the same size, so I wouldn't worry too much about the order you take them out or put them back in. So we've got a stripped screw already, so be careful. So that's our 4 screws out. As you can see by these cases, there are clips, so we just need to pop those clips. So let's do that. And gently prise it apart, and off it comes. So this is your antenna shield. There's 2 contacts there, 2 contacts here. So we'll put that to one side for now. As I said, I'm not going to remove that. I suspect it's glued in, so I don't want to damage it, so we'll leave it there for now. It's not necessary for the purpose of what we're doing. So 2 more screws we need to remove. We have a screw here. Keep this separate. We also have a screw here. So this should lift up. You're probably also wondering, hey, we have 1 pin here. Yeah, the 2 other pins are actually still in the case. They have detached. So they touch against these contacts here and here. These 2. So we have another screw down here in this hole. Let's remove that. And there is another one down here. So that's it. We should be able to remove the whole flipperzero. That's the inside of the case. So let's just try the carbon fiber case. It's a little bit tight. Yeah, it looks like we may have a size issue. Be careful not to force it too much. But as you can see, it's pretty tight in there. So let's edge that out carefully. Let's try one of our other tabs, see if this one fits. Again, pretty tight. You probably need to reprint this with slight increase in size, probably 2, 3, 4, 5%, something like that. So be careful removing it. Let's try our PETG one. Again, fractionally too small. Yeah, It's not going to fit. But what it does do is it gives us a look at what that looks like with the PETG. But at least we're starting from a good place. We know what we need to print. We know what we need to do. We just need to adjust the sizing. So let's go do that. Okay.
One eternity later.
24 hours later. Where are we? Well, 3 more prints. 2 with supports. 1 without. We've done it at 100.5% scale, 101% scale, and this one 101.5% scale. And finally we've got something that kind of works but kind of doesn't. So if we take our flipper, the interior, and we try and sit it into this, it goes most of the way in. It fits pretty good on one side, but it won't fit on the other side. And the reason it won't fit, well, obviously we rescaled it, so everything is moved. So everything is in the wrong place. So this is why it won't fit. So overall, this has been a bit of a failure. And, well, it's been a total failure. So I have several dozen prints, of which none are useful. So what next? Well, firstly, I don't have the knowledge to be able to re-edit this, so I don't think I will be re-editing this case. I think it looks good. I think it has potential. I think the flipper would look great in a black case, especially carbon fiber. But yeah, it's not going to be this case. So unfortunately, there's been a bit of a bust. But it's not been a complete waste of time, because we've learned some things. Well, firstly, test printing without planning will waste a lot of filament and a lot of time. Here are some things you might consider when you're planning to do a print of something new. So firstly, I did multiple materials in high quality on multiple machines before I ever did some testing. So I would say, firstly, pick a material, work with that material. If you have multiple printers, use only one of them. Don't keep changing printers. If you keep changing printers, you're going to keep changing settings, you're going to keep changing the print type, and you're going to waste a lot of time and a lot of filament. Keep a record of your settings on the slicer, and if possible, save off each print and do a fresh start for each new test print. This reduces the risk of you losing track of your prints and track of your settings, especially if your last print is worse than your previous print. Maybe going back might be difficult. So keep a record of those settings. Run your prints in draft mode with larger layer heights and faster printing settings if you have them, so you can prototype it quickly. Avoid multicolored, multi-material at this point. It's only going to slow your prints down. Test each prototype as you print. Adjust your settings accordingly. Don't just keep printing and assuming everything's okay, so test them out. If you get a satisfactory fit, you can look at testing things like other materials, you can look at testing your supports, and you can still do that in draft mode, so you don't waste too much time, because these prints can take a long time to perform. And then finally, when you're happy that you have a final version of your print, you can do a final version with high quality, multi-material, supports, colors, etc., etc. This is likely the best way you're going to save your material, save your electricity, your overall costs, and most importantly, save your time. But anyway, so this isn't a total loss. Let's do something useful with all these prints. Let's figure out what's the strongest. Not going to do anything scientific. Let's just see what it takes to break these things. Let's try that out. Which of these will survive a hammer? Let's see. So we got our PLA. Pretty brittle. ASA. Wow, nothing. PETG. And finally, carbon fiber PLA. What have we learned? Well, hammers break things. But what we can definitely say is our carbon fiber PLA is brittle, but not as brittle as some carbon fiber or some PLAs. PETG, a little less so. Pretty good. Held out fairly well. ASA, well, this is the champ. It did break along the layer lines, but yeah, I mean, that's what I'm building things with if I want something that's gonna take a hammer hit. And of course, polycarbonate, yeah, it's pretty brittle. PETG, carbon fiber PLA, and PETG again. So, in order of strength, I would say weakest polycarbonate, second weakest carbon fiber, PETG, and then the champ, ASA. So, this hasn't been a waste of time. Maybe. That's it for today's video. Hope you found this exploration of custom 3D printed shells for your flipperzero interesting and informative. If you've enjoyed the video, don't forget to give it a thumbs up and hit that subscribe button for more content like this. As always, feel free to leave any questions or suggestions in the comments below, and I'll see you in the next video.